All right, you will see a question like this on the exam. For the most part, it will be factored. You might want to look at certain thing. When I say factored, I mean this is not factored yet, so you might want to make sure that everything is factored. A good portion of the factoring will be done, but you just want to double check. So what we're going to do is we're going to factor this out to it's the difference of squares. Squares x plus 4, x minus 4, and then 3, x plus 4, x minus 2. If you remember, what we're looking for are all these things up here. Vertical asymptotes. Vertical asymptotes, remember, happen when the denominator is equal to 0. Okay, so if I set x minus 2 equals 0, x equals 2 provides a vertical asymptote. Okay, now normally we would also take x plus 4 and set that equal to 0 and get 1 at negative 4. However, that factor of x plus 4 shows up top as well. So that actually tells me that when x plus 4 is equal to 0, so x equals negative 4, because they cancel like that, it's not a vertical asymptote, but it's a hole. Okay? And if it's a hole, a lot of times what we want to do is locate the location of it. So what we do is once everything cancels out, we have now x minus 4 over 3 x plus 4, sorry, 3, they canceled, so I guess x minus 2 is it. Okay, so that's what we're left with. So now the y value of the hole is going to be located by plugging back into here. So we're going to have negative 4 minus 4, which is negative 8, over 3 times negative 6, which would be, what, positive 18? Negative 18, sorry. Negative 18. Just double checking that. Put a 4 in there. 6 times 3 is 18. Negative, yeah. Both reduced by 2, so I get 4/9. So I have a hole at negative 4 comma 4/9. Just be careful with that. That's the one intricacy that's a little bit different. You just can't blindly approach them and say, I'm always going to set bottom equals 0, set top equals 0, that kind of stuff. You've got to look for those locations. Now, the next thing we're going to do is find the x-intercepts and y-intercepts. Okay. X-intercept is when the numerator is equal to 0. Okay. Well, when the numerator is equal to 0, I'm going to have, it's not going to be a hole there. Okay. You can't have, basically what I'm trying to say here is we want to do everything with this depreciated function after it's been canceled. Okay, so set the numerator equal to 0. I get x to be 4. Okay, so 4 comma 0 is going to be my y-intercept, or sorry, my x-intercept. Okay, my y-intercept is when x is 0. So let this be 0, and I let that be 0, so I get negative 4 over negative 6, so I get a y-intercept at 0 comma 2/3. Vertical asymptote at 2, hole at negative 4 4/9, and then an x-intercept of 4 0, a y-intercept of 0 2/3, and then the last thing we need to know is if there's a horizontal asymptote. So a horizontal asymptote, what we're going to do is we're going to compare the leading coefficients, because this is to the first, this was, just kind of rewriting this over here. There's x minus 4 over ultimately 3x minus 6. I distribute that 3 through. Because these are both to the first power, all we have to do is compare the leading coefficients. So it's 1/3. So I have a horizontal asymptote at y equals 1/3. Now I'm going to go to GeoGebra real quick and just plot these things, plot that equation, graph that equation, and that should provide us verification that we're right. right, so I think we had all kinds of things open. X squared minus 16 on top, divided then by 3 times x plus 4 and x minus 2. Okay, so then we see here that x-intercept 4, 0, going back, just double checking. X-intercept 4, 0, y-intercept 0, 2/3. That looks like 0, 2/3 there, and let's just double check. Let's type in 0, 2/3. That's my y-intercept. Let's say we had x equals 2 as a vertical asymptote, and that's what that's looking like. We had y equals 1/3 as a horizontal asymptote. That's what that looks like. And then we had a hole at -4, 4/9. So I'm going to find -4 over here. And what I'm going to do actually is move a. So I'm going to move a here. Move it over to -4. Oh, I got to attach it. Okay, so let me move it. There we go. See if I can get this -4. All right, so it's not letting me, if you see here, it's not letting me get all the way to -4. But if I said if I was able to get that to change to -4, that would it would just disappear, tell me I'd have a problem somehow. I'm not sure how GeoGebra would tell me I'd have a problem. But there is a hole right there. If you were to type this on your TIA 384 into Y1, and then go to your table, at -4, it should say undefined. Okay, with this question, solving logarithmic equations, what we need to do to solve logarithmic equations, we either need one log on the left-hand side and no logs on the right-hand side, or one log on the left or one log on the right. You can't have any more or any less than that. So in this situation, it looks like we're going to have a log on both sides, but we need to use our log properties to adjust for this. Remember that the log of A plus log of B is equal to log A B. And we also had the log of A to the C is equal to C log of A. Those are the two that I think we're going to need here. I'm going to combine this first there because that looks like something like this. So I'm going to multiply the arguments together. So I'm going to natural log of 18 times x minus 9 halves times 18, so 9 times 9 basically, so 81. So minus 81 equals 2 ln of x. So 2 ln of x, that looks something like this. So I'm going to take that 2 and write it as an exponent, so ln of x squared. Now what we have is just a general equation where log the ln on the left is equal to ln on the right. Well, that's log base e of 18x minus 81 and log base e of x squared. It's saying that these two logs, basically the exponents that I raise e to, is supposed to equal 18x minus 81, and the log that I raise, or the exponent that I raise e to, should equal x squared. So these two things have to be the same. So I'm going to say x squared is equal to 18x minus 81. So x squared minus 18x plus 81 equals 0. That's going to give me x minus 9 and x minus 9 equals 0. So I get x to be 9. When you're done with these, just make sure that, because sometimes you might get something, you got double root here. Sometimes you might get two answers. You got to make sure that you remember to take the logarithm of positive numbers. So if you get a number that you plug in here, that has to be positive, that has to be positive, that has to be positive. And anytime a negative number plugged in there would give you an indeterminate value, so it would be an answer that you kick out. In this case, x is got to be 9. This is kind of the variant problem where we get logarithm on one side. Okay, so if I get logarithm on one side, automatically all I have to do is use the definition of logarithm. It said log base a of x is equal to b if and only if a to the b is equal to x. Okay, so that's what I'm going to do here. This looks something like this. So I'm going to take 8, which is that value there, it's that base, which is corresponding to the a here, and then it take this definition says we're going to raise that to the b. So the b in this case would be 2. So 8 squared is then equal to x. Well, x is going to be the 4 minus x. 64 equals 4 minus x. Subtract 60, or subtract 4. 60 is equal to the opposite of x. X equals negative 60. When I plug x back in, I get negative 64 here. Or sorry, positive 4 minus a negative 60, positive 64. And that should make sense. Log base 8 of 64 equals 2. 8 squared should give me 64. This question is a system equation. It's trying to help you set this up. It says a gas station sells regular gas for $2.20 and premium gas for $3. At the end of the day, 330 gallons of gas have been sold, and receipts total $7.98. How many gases of each type of gas have been sold? I'm going to go with regular gas, and I'm going to go with premium gas. Okay, regular gas is $2.20. Premium gas is $3. That should total then $7.98. Okay. It also says that regular gas by the gallon plus premium gas by the gallon, I should have sold 330 gallons of that. Okay. Now use whatever system you want to, technique you want to, elimination, substitution, matrices, whatever, to solve that. You should end up with those two results if you do this problem. Here we got a sequence is defined recursively by the given formulas. Find all these terms. Okay, recursively means it's using previous terms. So if I've got two previous terms being used, they've got to give me a starting point of the first two terms. So the first term is 9. So a sub 1 is 9. A sub 2 is 6. Now a sub 3, okay, so we're going to say this here is a sub 3, should equal a sub n minus 1. Well, n is 3, so we're looking at a sub 2 right there. Plus then a sub n minus 2. Well, n again in this case was 3, so subtract 2, give me 1, so a sub 1. So now a sub 3 is a sub 2 plus a sub 1, so I add those two together, I get 15. A sub 4 then is again, starting back over this, it's the previous term, a sub n minus 1, which is a sub 3, plus then a sub n minus 2. Well, n minus 2 would be 2, So we a sub 2. So I'm taking a sub 3, which was 15, adding to it a sub 2, which is 6, and you get 21. And I do the same thing for a sub 5. So that's going to be a sub 4 plus a sub 3. A sub 4 was 21, a sub 3 was 15, and I get 36. So let's find the nth term in the geometric sequence with the given first term of the common ratio. Okay, so every time we see one of these, they should be in the form of a sub n is equal to my common ratio raised to the n minus 1. Okay, I'm sorry, a sub 1 times my common ratio, n minus 1. So a sub 1, they're telling me, is 9. R, my common ratio, is 6. I raise that to the n minus 1. Now they ask me for the fourth term, so that's the n value. So I just go 9, 6. 4 minus 1 would be 3. 6 times 3 is 216. Or 6 to a third is 216 times 9, 1944. Okay. Eventually, I'll do this one. And this can kind of parlay off of what I was going to say. This is a sigma notation, so this is just evaluating. Okay, we're going to evaluate 9 times 2/3 at k minus 1. Okay, well in this case, they're telling me if the first thing I do is k is 1. So k minus 1, 1 minus 1 would be 0. So then that's going to give me 9 as a total. Now this whole thing here tells me that k keeps increasing. It's going to go to 2. So I'll go 9 2/3. Now k minus 1, where k is 2. 2 minus 1 would be 1. That's going to cancel, gives me 3 times 2, which is 6. Now k is going to grow to 3. Okay, so I'll go 9 2/3. 3 minus 1 is 2. Okay, so that's 9 and 4/9. So that's going to go to 4. Let's cancel. And now k goes to 4. So 9 2/3 to the third. So it'll be 9, 8, and 27. So cancel, gives me a 3 down here. So 8/3. And then k goes to 5. 9, 2, 3. That's 4. So it's 9. Okay, 2 times 2 times 2 times 2 is 16. 3 times 3, 9 times 3, 27, times 3 is 81. Those are going to cancel, gives me 9, so 16/9. And now, so I stop because I start at k is 1, and I stop when I get to k being that number up there. Now I'm going to take each one of these results, and I want to add them together. And that should give me 211 over 9. At some point, you might see something like this, where n is equal to 1, and they want you to go to infinity. And they're going to ask you maybe something like 2/3 to the n minus 1. Okay. Well, that situation, we need to know what our terms are. Okay, our first term is going to be, when n is 1. So basically these are telling me how to sum the sequence. And this is ultimately saying this is a geometric sequence. And to go to infinity, well, obviously we don't want to write out all the infinite values. So we need to realize that this format here is showing you that we have a converging geometric series. And when I say that, it's infinite. It's converging infinite geometric series. And if you remember those, I said if the absolute value of r is less than 1, it converges to a particular value. And that's what we've got here. R is less than 1. The absolute value, it's less than 1. And the formula was then that that sum was equal to a sub 1 over 1 minus r. Well, a sub 1 here is that first term. So in this case, it's going to be, if I plug in my first term here, n being 1, I get 0. 2/3 raised to 0 is just 1, right? So my first term is 1. And then 1 minus r, so 1 minus 2/3 gives me 1 over 1/3, which is 3. So I'm going to converge this answer right here to this problem would be 3. And that's something you might want to know for the test.